I am Dr. Erica Suosaari. I'm a science fellow at Hamelin Pool, and I've been working on the stromatolites for the last 5 years. This image is taken from the Boulder province, what I would call the Boulder province, the southwest quadrant of Hamelin Pool. This area is characterized by these Seif stromatolites, which is what you're looking at here in this image. They're really long bands of stromatolites that often extend for kilometers. What we're walking down now is a camel track, and a bit of Hamelin history is that camels used to bring the wool from the pastoralists down this track to get to deeper waters so that the wool could be taken out to sea. And this track that you just saw was cut about between 50 and 100 years ago, and still stromatolites haven't filled in that gap. So it's a good place to walk out and observe the stromatolites. So the Boulder province has Seif stromatolites up and down the entire margin, and that is mostly due to the really low gradient of this area. What you're looking at now is the top of a Seif stromatolite in the intertidal, topped with pustular mat. Pustular mat is dominated by the cyanobacterial Entophysalis. It's a little coccoid cyanobacteria. So here you can see down a Seif stromatolite, and you can see that very much like a Seif dune, which is a long straight dune, this Seif stromatolite has a windward side and a leeward side. And on that windward side, which is facing shore, it's got scalloped front edges, which are in the direction of wave translation. So those waves that are coming to and from shore are kind of back cutting the front of that stromatolite and making these scalloped edges. Now you can also see in this image that the Seif stromatolite backsteps, and dunes often do that. So another question might be, are these Seif stromatolites growing on top of old dunes that are underneath them? These stromatolites are topped by pustular mat because of where they are in the tidal zone, or what their absolute elevation is. I call this crusty pustular because it's also mixed with another cyanobacteria called Dicathrix, and that gives it a bit of a different composition. As you pan back here, you can see the camel track. Here I am in the Boulder province taking a water sample. I do this about every month to look at the changing water composition throughout the different seasons. This is a good example of how the microbial community changes with depth. So as you're looking straight towards shore, you can see really dark stromatolites. But here, closer to the subtidal, you can see that the stromatolites don't have that dark pustular mat that's covering their surface. Now they've got what we would call a smooth mat, which is dominated by coccoid cyanobacteria. But the color is very similar to the surrounding sediments, and so they're really hard to see from up above. Now, as we're walking down the camel track to head back to shore, you can see these Seif stromatolite bands and how they're really dominated by that dark pustular mat. So if you're going out into the sun, you get a tan because your body produces that melanin to protect you. And in the same sense, these dark cyanobacterial mats are also producing a pigment that helps protect them from the sun. In this footage, we're up in the northwest corner of Hamelin Pool. It's what I would call the Nanga province. And I'm taking a water sample, both from a piezometer and also from Hamelin Pool. This is a beautiful area of Hamelin Pool and really understudied So gorgeous individual and merged stromatolites covered by a smooth mat. So this is the top of a piezometer sticking out of the ground in the Nanga province. And you remove the lid from the piezometer and that reveals a tube going down into the subsurface. Then this tube gets connected to that tube. And that tube then gets connected to the peristaltic pump. Now, the peristaltic pump pumps the water from the subsurface into the sample jar. Once completed, we need to put a bit of silicone grease around the threading. This prevents the threads from getting rusted, so that the next month when we come to check our sample we can still access the tubing. Here I'm taking a sample of Hamelin pool waters. Then I'll bring the samples back up to the ute for testing. Here I'm taking dissolved oxygen, temperature, and salinity measurements with the YSI. This is a pH meter, and here I'm recording the pH and temperature of the sample. Again, it's critical to accurately record your data. From each sample, I also take subsamples. To do that, I take a large syringe and first clean out the syringe with a bit of my sample water. Then I pull a full syringe of the sample. In my triplicate samples, one bottle already has mercuric chloride in it. Mercuric chloride will kill any living thing in the sample. I put a filter onto the syringe and push the sample through that filter paper to strain out any particulates. Another sample bottle has hydrochloric acid in it, and this will dissolve any carbonate material. Then I repeat the process. The third sample bottle in the triplicate is a blank, meaning it doesn't have any other chemicals in it. I remove the filter paper and put it into a baggie. This filter paper will then be X-rayed for mineralogy. I have to move quickly. Oh, that's cool. We are visiting the western margin of Hamelin Pool, where we find some blue holes. Near the blue holes, I'm going to take a groundwater sample. I take a groundwater sample here every month. At times during the wet season, I can't pull from this piezometer because this whole area gets covered by water. Then the water begins to evaporate, and you're left with these depressions filled in with water that are blue holes. The water in the blue holes is very salty. In this hole, you can see a lot of dead fish from the recent evaporation. This water has become too salty for these little fish to live. Some of them are really deep. This is a really large area that's covered with water, and in the center of this you can see this dark blue hole. That's a really deep hole. You could actually get in there and swim if you wanted to. Not that you should. But this water that's around the outside of it will evaporate, and that will close in so that eventually you just have this small dark area of deep water. Along the margins of the blue holes you can begin to see these white salt crusts, and that's part of the evaporation sequence. So once water begins to evaporate, once you get about 50% evaporated, you begin to get minor quantities of carbonate material that precipitates out of the solution. And then after you evaporate about 80% of the water, you get minerals like gypsum that start to precipitate. And then after 90% of the water is evaporated, you get halite precipitates, which are like salts. And in the last 95% of evaporation, you get potassium salts and magnesium salts. So you begin to really build up these crusts along, well, even along the surrounding sediments. You can see a lot of brecciated rocks, and those brecciated rocks are also caused because of this evaporation sequence. So once all this water begins to evaporate out, these minerals precipitate, and these minerals also, they often form in cracks and expand. That helps cause the weaknesses in the rocks that lead to brecciation. The blue holes often get really hot, and they're actually quite deep. And it's believed that there's a bit of a flushing mechanism with Greater Hamelin Pool, so that the water is able to move back and forth between them. It's important at this location that I also go to Hamelin Pool to take a water sample, which is actually quite a walk. This is Nilima embayment, the southernmost portion of Hamelin Pool, and part of what I call Nilima province. This province is characterized by an extremely low gradient that's covered by microbial sheet mat. Sheet mat is unlithified to weakly lithified microbial mat that's not building stromatolites. This is pustular mat, and this whole embayment is covered by it. Here I'm taking a groundwater sample from beneath the sheet mat. This is a beautiful picture of the tide coming in, and you can see the different areas of the microbial sheet mat that's begun to get wet. So in addition to the groundwater sample, I also have to walk out to deeper waters at the end of the sheet mat to pull a Hamelin Pool water sample. So first I rinse out the bottle with some Hamelin Pool water, and then I fill it so that I can come back and test the parameters and compare that with the water pulled from the piezometer. You can see a lot of tracks made in these sheet mats from over the last 100 years, and that changes the compression in the mat, and so that changes the way that the water is able to be held on to, and so that has a bit of an effect on what type of microbial mat can exist there. This is tufted mat. The dominant cyanobacteria in this mat is called Lingbia. It's a filamentous cyanobacteria, and when you break apart the mat, you can see the filaments kind of sticking together and pulling apart. And once this mat starts to dry, you get these peaks that pull up on the mat, and they're reaching higher to get to the sun. When this tufted mat, made by the dominant cyanobacteria Lingbia, produces these pinnacles, it's a morphology shared by billion-year-old microbialite structures. But this dolphin is a reminder of the extremely inhospitable environment Hamelin Pool can be. Once the water samples have been collected, we bring them back up to the ute so that we can immediately test them. This is one of the most important areas in Hamelin Pool, in my opinion. This location is the Playford Transect, part of the Flagpole Province, and this is the very first location where Dr. Phil Playford cut in a transect to examine stromatolites over a period of time. I have a piezometer in this location, but unfortunately I can't seem to find that piezometer.
Why?
It appears that a bunch of sediment has been moved in to shore and covered up the top of the piezometer. Or else someone nicked it. And this is part of science. We were never able to find the piezometer.
So that's pretty much it.
And the last slide is of a mulla mulla. That's a very characteristic plant of this area.
Good. Excellent.
And once you drive through that plant, if you drive the truck through a lot of those plants, they put this fluff out and it goes into the radiator, shuts your car down. They're beautiful, but they suck. So we have to put shade cloth on the front of the truck during another month from now when these get to seed and they're ready. So that we'll put the shade cloth on the front of the truck so that it keeps all the bits that come off there from going into the radiator, because it takes your car out like that.